Assalamualaikum and hello everyone. We are from group 15 and I'm Aisha.
I'm Esther.
I'm Yuhui.
I'm Nurko Azizi.
And I am Nisha.
So we are here to present to you our mini project, Spray Dryer. So what is Spray Dryer? Spray dryer is an equipment used to produce a dry powder from a liquid by spray drying process with a hot gas. So this hot gas usually used as air as the heated drying medium. But for flammable solvent, nitrogen is used. So commonly, this spray dryer is used to dry thermally sensitive materials such as food and pharmaceutical. And this spray dryer is invented by Samuel R. Percy in 1872. And this traditional spray dryer is lack in efficiency. So that's why we decided to improve this spray dryer to increase the efficiency.
Moving on to the literature review. In 1969 and 2016, Baltas and Govin and Shakiba et al. Both mentioned that there are two main categories of the spray dryer. The first one is the co-current. It is typically used in temperature-sensitive processes, and the next one is countercurrent. In 2015, Francia et al. Has announced that countercurrent are limited. However, they have incorporated countercurrent spray dryers with swirling flow. Modern study has been improved for the spray dryer, where common improvements include, number one, the interstage and multi-stage spray dryers. In 2008, Chow et al. Found that the degree of crystallization increases with temperature. Second, CFD. CFD has been used as an important tool to compare the performances in nozzles and chambers of the dryers. Third, MDSD modeling and MDGs, which has been discovered by Wu et al. 2011, in which MDSD means monodispersed spray system and MDG means monodispersed generators. They were first used in printing, and it is used to produce droplets with uniform volume. Next, we will focus on spray dryers. Spray dryers with two fluid nozzles, which is mostly used in the pharmaceutical industry. However, Puzes et al. In 2018 has researched that its mechanisms are poorly understood. Various efforts have been made by Vicente et al. 2013 and Dennison et al. 2016 to correlate droplet size with operational conditions of two fluid nozzles. A recent study also uses spray dryers with two fluid nozzles in determining the process stability of the developed protein. Next. There are new and improved spray dryers, including, number one, chambers with different sizes, number two, heat recovery processes, and number three, spray dryers using 4 fluid nozzles instead of 2. Hence, our study will be focusing on 4 fluid nozzle spray dryers. These spray dryers has 2 liquid and 2 gas passes. It can overcome the problems of finding and using a common solvent.
So for spray dryers working principle, we have 5 general processes. The first one is concentration of feed, meaning that the liquid contents need to be increased so that it can result in a better yield for the spray dryer. The second one is atomization process. What happens is that a nozzle or rotary atomizer turns the liquid feedstock into small liquid droplets. The third one, droplet air contact. Moisture evaporation occurs as atomized droplets exposed to a hot stream of air. In drying process, after the droplets exit the nozzle or atomizer, They need to be dried to form a powder that can be easily packed and transported. The last one is solid separation. The powder is collected at the bottom of the spray dryer, and this happens in the cycle. The applications of spray dryer, we have 4, and the first one is pharmaceutical products. They produce penicillin and antibiotics. The second one is processing of instant coffee or tea whiteners, which is creamers. And they also use spray dryer for soap and detergent manufacturing. And the production of milk and dairy products to produce them into powder form. For pros and cons of spray dryer, for advantages, it has good quality control, where product quality can be effectively controlled and easily maintained. The second one is that the corrosion problem can be reduced, where products will not contact metal surfaces until it is dried and the drying chamber remains dry. Next, pharmaceutical products can be dried at atmospheric pressure and low temperature. Spray dryer also handles a wide range of production rate and provide extensive flexibility. And for its disadvantages, spray dryer is bulky in size, hence is expensive to install. The second one is that it has maintenance issue, where it is difficult to clean after use, and nozzles are prone to clogging and abrasion at its mouth. The third one is low thermal efficiency, where spray dryer requires a very large flows of hot drying gas, and a lot of hot air is wasted during the process.
So I'm going to explain about the typical design. So at your left is the typical design of spray dryer, where we have the feed, the atomizer, the drying chamber, and the cyclone. So I'm going to explain about the atomizer, which is we use 2 fluid nozzle. In this 2 fluid nozzle, there's 2 paths, which is one is for liquid feed and the other one is for compressed gas. So for 2 fluid nozzle, there's 2 types, which is one is external mixing nozzle and the other one is internal mixing nozzle. In external mixing nozzle, the mixing happens at the end of the nozzle, which is at the bottom. And for the internal mixing nozzle, the mixing happens within the nozzle, as you can see in the figure.
I'm going to talk about the problem that we face in the spray dryer. The main problem is low thermal efficiency. The energy consumption of spray dryer is high and have relative low energy utilization. This may result high energy waste and cost of operation. Next, the second problem is the bioavailability of the particle produced by the spray dryer is low. Thus, it will affect the applied dosage and the drop down to the nanoscale. The third one is the 2 fluid nozzle is not available for suspension and concentrated solution. Thus, the droplets will contain solid components and might be dry in the mixing chamber. Sludge will gradually accumulate on the chamber wall and interrupt the feeding of the solution.
So for the improvement, we choose to improve the atomizer for spray dryer, since the atomizer is the most important thing in the system, which we change from 2 fluid nozzle to 4 fluid nozzle. This is our design for 4 fluid nozzle, which consists of 2 chisel shape, which have 4 orifices, 2 gas flow stream and 2 liquid flow stream. How it works, the first 2 liquid solution supplies to supersonic flow and drawn toward the edge of the nozzle. Both liquid from separate orifices will be collide with each other at the conversion point of the nozzle. A powerful shock wave produced. The solution dispersed into small droplets, and the solution will be heated by air from 2 opposite sides of the nozzle to be dried. And the last one, the particle form into the fine particle. Next. I will explain about the advantage of 4 fluid nozzle, which the first one is can use 2 solutions in one time. As I mentioned before, there are 2 orifices only for the solution. Next, it's not form a sludge due to continuous flow of liquid in the flowing zone and make a wash of the surface. And then the shape of particle will rigidly granulate. It reduces time of drying process, and the most important thing is characteristic of the particle which decrease in diameter. This characteristic is one of solution to the few problems that been faced by in most industries, especially in pharmaceutical. The production of microparticle with nanoscale substructure which maintain the stability and efficacy of the particulate dosage which remove the most solvent. It also can increase dispersibility and fast the delivery for pulmonary drug. Also, the dissolution of drug can increase due to decrease in crystallinity of particle. This focus on dosage of drug to reduce the side effect to the patient who involved with long administration. And last but not least, the thermal efficiency will be higher when used for fluid nozzle than two fluid nozzle. Also, the amount of particle that will be produced 400 times for 4 fluid nozzle rather than 2 fluid nozzle.
So for the calculation, we're going to calculate the thermal efficiency of spray drying, which is we use this formula, which is N is equals to inlet hot air temperature minus the outlet air temperature over the inlet hot air temperature minus the ambient temperature times with 100%. According to the journal that we found, we have compared 2 fluid nozzle and 4 fluid nozzle, which is this is the result, where for inlet temperature for 2 fluid nozzle is 125 and 4 fluid nozzle is 150. And the outlet temperature for both is different, which is 70 and 65. But the ambient temperature for both is 23 Celsius, which is the same. So at the end, we get the result, which is the thermal efficiency for 2 fluid nozzle is 53.9, and for 4 fluid nozzle is 66.9, which is higher than 2 fluid nozzle.
Now I will explain about the mass balance of spray dryer. As we all know, mass balance is about mass inlet equal to mass outlet. Now we are going to look at our solution. This is the solution for the mass balance of two fluid nozzle. We have two inlets, and after we did the solid balance, we get the mass of product is equal to 0.98 gram per minute. The main difference of 4 fluid nozzle with 2 fluid nozzle is that 4 fluid nozzle have one more inlet than 2 fluid nozzle. So we have total of 3 inlets. After we calculate the solid balance, and we get NP is equal to 10.05 gram per minute. This is much higher than the 2 fluid nozzle. So as a conclusion, we have spray dryer is a useful operation unit in pharmaceutical area. A suitable nozzle is able to increase the efficiency of the dryer as we seen in our calculation. It has increased 30%. The dissolution rate of poor soluble drug in vivo had increased, and there is no sludge formed on the surface of the nozzle. That's all for our presentation. Thank you.